Hello, good afternoon, good morning, good evening, wherever you are. Thank you for joining Spantech's seminar today. The topic of this seminar is looking at ozone and chlorine dioxide, traditionally very difficult gases at ppm level to bottle safely and stably as calibration gases in cylinders. We'll be looking at generators and some other offerings later on from Spantech. However, the main speaker for this talk is Kurt Ballard from ACD, and he'll be talking about his generators. For those of you who have not attended a Spantech seminar before, we encourage you to ask questions. That's always encouraged. There is a chat box which you can see on the right hand side of your screen. If you feel like if you have a question, please put that into the chat box. We will collect all the questions at the end and answer them, as we always do. We generally won't answer them during the course of the seminar, but there is time at the end to answer questions. If you want to try the chat box, quite nice if you want to put your name and which country you're from in there. It's always nice to see where we have people from. In addition, during the course of the seminar, we will also be asking you, I think, 3 or 4 questions in the form of polls, just to understand where you are and what you're doing. And also there'll be 2 or 3 handouts that you can download at the end with further technical information about what we've been talking about. The further information is always available on our LinkedIn page and our website. You can access these. That will always give you information about our ongoing seminar program, as well as other technical information about the products that we deal with. So with no further ado, I will pass over to Kurt. Kurt is the president of ACD. He's been working with ACD for 15, 20 years, I forget, long enough, and he's still smiling, which is always a good sign. And he's going to run us through the difficult gases, as I mentioned, the chlorine dioxide and ozone solutions that they offer at ACD. And as I say, please ask questions as we go along in the chat box. I will collect them at the end, and we will go through them. So Kurt, over to you.
Thank you, Chris. Good day, everyone. Good to see you. As Chris mentioned, what I'm going to go over with you guys is how do we calibrate these sensors for these difficult gases that are hard to find calibration sources for. So ACD, as a little bit of background, started as a company to try to make chlorine primary gas standards, and this is in the late 1980s. And so our beginning gas was chlorine gas, because at that time you couldn't get chlorine in a calibration gas cylinder. There was no way to calibrate it. And so that was the impetus that started ACD back in 1988. And we're going to talk a little bit today about these particular 3 gases. Chlorine dioxide is a gas that if you compress it into a cylinder, it is explosive. So it can't be put into a gas cylinder. Ozone is very reactive, and so is chlorine. So the problem with these gases is they're so reactive, when you put them into an aluminum cylinder, even with a lining, or the inside of the cylinder is trying to be non-reactive as possible, still they tend to react. So we have on-demand gas generators that produce the gas on demand and can be used to calibrate these difficult 3 gases. So first we're going to go tell you what we've got. We've got the scope of the presentation is we're going to go over what ozone, chlorine, and CHLO2 are, traditional calibration methods, and then the advantages of being able to generate these calibration gas levels on demand in portable gas generators. So I'm going to start with ozone. All of these are oxidant gases that we're talking about today, but it's got a lot of applications, so you'll find them all over the place. It's that smell that you smell during a lightning storm. That's ozone being generated from the lightning, exciting oxygen into O3. It's very reactive, so it doesn't stay that way long, and it goes back to being oxygen very quickly. But it, as a bad gas to be around, and something you need to detect for, it attacks your mucous membranes and your respiratory tissues. So right away, if you're in an area with a lot of ozone, you get a sore, your nose and your throat get sore right away because it's attacking those tissues. Some of its uses are water decontamination, and it's used to bleach, whiten different materials like flour, things like that. It's used to disinfect clothing and air deodorizers. You've probably seen a portable ozone generator on a big scale for like a hotel room. They'll set them in a room where somebody smoked in there to kill all the odors in a room and get all the organics out of that carpeting and the drapes and stuff like that. And it's big. Ozone's also big in the food industry, in bacteria on food and bugs on grain. And the biggest users are water and wastewater plants, food processing, and drink manufacturers. A lot of bottled water. The last thing that goes into that bottle of water is a shot of ozone to keep all the bacteria out of it as it goes down the line. Chlorine is similar in that it's an oxidant gas, but it is so widely used. I mean, it's everywhere. The most common use is water and wastewater. Again, the good thing about chlorine, as opposed to, say, ozone or chlorine dioxide being used to decontaminate something, is that it hangs around longer. So if you put water into a water tank, if you put chlorine into a water tank, it's going to last longer and keep decontaminating the water, keep the algae from growing for longer. It's less effective, but it lasts longer than, say, ozone or chlorine dioxide. But the problem with chlorine is everybody knows what it is, and they get lackadaisical about it. They're not afraid of it because they know what it is. And so this, people's familiarity with chlorine sometimes causes problems where they've got a storage area and they've got chlorine and they don't worry about it because they know it's there, and they end up hurting themselves with that chlorine because they're not sensing for it and they're not afraid of it. And you got to have a good, healthy fear of chlorine gas. So chlorine dioxide, as I mentioned before, it's becoming more and more popular. It was used, originally we would see it in pulp and paper where they would use it to bleach the paper. Very popular still in pulp and paper industries, where they make tissues, Kleenex and paper towels and things like that. It's also used to fumigate buildings. Back when we had all the anthrax scares, they would pump chlorine dioxide into buildings to kill anything that was in there. And they're still used widely in, say, poultry operations where they find salmonella in a meat packing plant or a poultry plant. They'll do the same thing where they evacuate the building, pump in chlorine dioxide, and it kills all the bacteria, any biological species. And so, of course, that means it could kill us. If it can kill anything biological, we are one of those things. So you have to have a healthy respect for chlorine dioxide gas. Very reactive, very strong oxidizer, and becoming more and more widely used. So talking about how we used to calibrate these sensors, sort of the old school method was a pressurized compressed gas cylinder was used for a standard. It's still used today for most calibration gases, where you put in a known amount into a compressed gas cylinder, a low level of the gas in question, and then you use that compressed gas cylinder with a regulator to apply it to a sensor, and then adjust that sensor to read the correct amount. So that's the basics of how do we calibrate a sensor. But gases like we're talking about today, ozone, chlorine dioxide, as soon as you put it into a compressed gas cylinder, chlorine is one that you can put in. As soon as you put it in there, it starts to react, no matter how much you try to treat the cylinder. It's just a very difficult thing to do, even with a gas that can be compressed like chlorine. Chlorine dioxide, again, you can't compress it, it immediately becomes explosive. And so there is no option to even put it in a cylinder. So the advantages of our products at ACD are an on-demand gas generator. So these gases are not stored anywhere, they're not compressed. And so there's a couple different ways we do that. One is electrochemical. So electrochemical generation uses these stable building blocks that don't degrade over time. So what we're saying is you can have a gas generating source. It's sort of like a galvanic cell. It looks a lot like a sensor, and it's stable as it's sitting there, and nothing happens until you apply energy to that cell and generate the gas that you're in question, like we're saying today, chlorine and chlorine dioxide. So that gas isn't stored, and these, as we generate these gases on demand, the molecules of the gas that are generated are then blended with a scrubbed background air, and you get a better calibration than you would even if there was a cylinder of the gas you wanted. So the basics of electrochemical generation, this is as old as time. A galvanic cell, there's a proportionality to, you can figure out if you want to generate a gas, you apply a certain amount of energy to a cell, a galvanic cell like we're showing here on the slide, and you get an X amount of molecules of the gas that you're trying to generate out. Time for me to wake up. Sorry. So now ozone is made in a different way. It's not electrochemically generated. It's made with a corona lamp. And so basically what you do is you take the oxygen molecules, apply an energy source to them, pass them across this light source, and excite the molecules into a state of O3, which is ozone. And so that's the source for an ozone generator is actually a lamp. Now the gas generation rate, again, we're talking about the electrochemical ones, the stable electrolyte. We can put a generating source together, put the liquid in it, and leave it for years. And nothing happens to it. Same with an ultraviolet lamp until we start to use it. So it doesn't sit on the shelf and degrade and go bad. And the other nice thing about gas generation, it's got a fixed determination. So the energy into the source, basically either way, electrochemically or through the excitation of the lamp, gives you enough a fixed amount of molecules of gas out. We blend that with a carrier gas, which is normally the ambient air in the room, and that gives us a certain amount of gas out. And the beauty about that is you can change it. So if you were to buy a chlorine gas cylinder at 5 parts per million, that's what you get. these generators, you can vary the flow rate, you can vary the output. So different sensors that want different concentrations of gases, you can calibrate all different things with one generator. The ppm gas generation is determined by the rate at which the gas is generated and then the flow rate that it's blended with. So basically, parts per million is a unitless number that is like percent, so 1 penny in 100 is 1%, and 1 penny in a million is 1 part per million. So ppm gas generation, we're talking about very small amounts, but these are toxic enough gases that that's all you want. You just want parts per million to calibrate your sensor. The sensor is an early warning device to tell people you need to leave this area. There's beginning to be enough gas present that it could get dangerous. So by calibrating and controlling these three variables, an exact stable concentration can be guaranteed. So what we have built into these instruments to assure that we're giving you exact calibration quantities of these ozone, chlorine, and chlorine dioxide gases that we're talking about today is the instruments themselves have a built-in mass flow sensor. As we know, air density changes with temperature and atmospheric pressure. So the air density at sea level versus here in Tucson in the United States, where I'm at 3,500 feet, the air density is different. And so if we generate X amount of molecules of a gas here, it's different than at sea level. So these mass flow controllers and sensors that we have built into these units ensure that we're always blending the right amount of gas with carrier gas with the right amount of, in this case, chlorine, ozone, or chlorine dioxide. And also the instrument current that is passed through these electrochemical cells has to be controlled as well. That gives us the amount of the gas in question, chlorine or chlorine dioxide in this case, to be blended with now the accurate amount of air. And then the efficiency of the source is also has to be compensated for or characterized so that we know exactly how much is coming out. They're not all 100% efficient. So this ability to very accurately produce low concentrations, that's the big deal about these gas generators, because what you want is really these very toxic chemicals, you want very low calibration levels to be generated. So the safety industry, the governing body in whatever country you live in, keeps lowering the acceptable concentrations. Here in the US, OSHA sets these safety levels and they say this is how many parts per million of whatever gas, as we're talking today, ozone, chlorine, or chlorine dioxide, that a worker can be exposed to 8 hours a day, 40 hours a week for 20 years. And typically that's where we alarm a sensor. So the worker is actually in an area that OSHA says he can be safely in 40 hours a week. But normally you don't want that. That usually means there's something wrong in the system if it's built up to that area. And so we want very low levels. And for a sensor, you want to calibrate near where you're going to alarm. These sensors are generally very good, very linear, but they're not perfect. So when you calibrate the sensor, you want to calibrate it near where your alarm level is, because the result of this sensor going into alarm is usually the evacuation of an area. So work stops. So you want to make sure that's a real alarm system, alarm condition, and that you evacuated the area for a real reason and not a false alarm. So these low concentrations of stored gases are tough to get. So chlorine in a cylinder at low levels, it's just really hard to keep. the the reactants of the generated gas is avoided as the gas immediately is used to calibrate. So it's generated, it comes out of a 5-foot hose, and it goes to the sensor. It doesn't, get stored into a cylinder for a long time. So this is definitely the best way to get low levels and the best way to get these particular gases we're talking about today. So again, we provide gases that can't be stored in compressed gas cylinders like ozone and CLO2, which is how we shorthand refer to chlorine dioxide, by the way. As I referred to earlier, a stored calibration gas in a cylinder is going to be exactly what you order. You've got to get X ppm, 25 ppm, 10 parts per million, whatever. And that's what's in that gas cylinder until it starts reacting. So if you've got several different types or manufacturers' sensors, you might have to have several different cylinders. As I mentioned before, these gas generators that we produce, you can just go through the display of the unit, set it at 1 ppm, calibrate all your 1 ppm sensors, then change it to 5 ppm, calibrate those. So a single source can make a lot of gas and can make it at different varying concentrations, which for the end user allows for less storage. The cylinders are date stamped, and at a certain point they just expire, and you just have to throw them away as well. So if you haven't used them, you lose them. So calibration gas contains a small amount, as we spoke, of the target gas, and the rest of the mixture is air. So a 5 part per million cylinder of chlorine calibration gas is 99.9995% air. So when you buy that cal gas cylinder, you're essentially buying air with just a little tiny bit of chlorine in it. So you can see where we can get large amounts of calibration gas from one small generating source. Some of the sources we have will put out as much gas as 100 58-liter cylinders of gas. So we're going to go over the advantages of these calibrators. We started in '88, so I guess we're in 33 years in business. We've got a worldwide network of service and support. We've got every gas detection manufacturer uses our equipment in their factories, and we've been in business for a long time. We've got a proven track record. We stand behind our products. We've been around forever. You can see all the gray hair I have from that. The instruments are microprocessor controlled, so you can put into one instrument, you can buy 5 or 6 different generating gas sources. So you have one instrument will do all 3 of these gases we're talking about today and several more. So one instrument can do, by swapping out the generating source, can do chlorine dioxide, and ozone. They're also expandable. We have other gases that we're not talking about today. The sources are tracked by life, so when you turn it on, it tells you how much life is left. That's the consumable part of that instrument, is the source. So it tells you so that you don't unknowingly run out, and it knows, it memorizes what you did. So if you've just used one of our gas generators at 5 ppm last time you used it 6 months ago, when you turn it on, it will come up to 5 parts per million in the flow rate that you used at the last time. And it's self-monitoring, so if it runs into an issue, it tells you, oh, the batteries are dead, or the source is used up, or the flow is wrong. It's self-monitoring. The mass flow sensor and controller compensates for altitude, I mentioned that earlier, and temperature, and it allows you to adjust. A lot of sensors have their own built-in pump system where they're drawing a sample from the air from somewhere. And so these gas generators that we manufacture will allow for adjustable flow. You can shut the pump off. The mass flow sensor will read the flow that the sample drawing sensor is pulling at, and it will provide whatever gas concentration that you tell it you need, however many parts per million that the manufacturer asks for. So these are primary gas standards, can be used for anybody's sensor on the market. As you see here, we've got a big range of different gas generators, from small ones for users that don't have a lot of sensors up to they're all small, but I mean low cost, I guess, that for people that don't have very many sensors. We've got bump testers, and then we've got the high end 100-hour units that last forever and can be varied. So they're small, lightweight, safe to ship, which is a big deal for people that have shipped cylinders over the years. You know how that cost goes. Since we don't have any stored gases, nothing is compressed in there. They're non-hazardous to ship. You have to check them because there's liquid in them when you take them out on an airplane, but you can take them with you, and as long as you check them and put them in the cargo hold. They're environmentally safe. I mean, you can imagine one generating source lasting as long as 100 cylinders. Just how much you can save money-wise, and they're very green products and what's going into the landfill. So these instruments are designed intelligently so that they can expand with your customer's need. If anybody is they're going to start with, say, ozone, chlorine, or chlorine dioxide generator, they can be expanded later to add, NO2, H2S, hydrogen. There's just different gases that can be added. Once you've got the instrument, you can just add sources as you need. So customers can start small and grow with it as they get used to it. And of course, we're always trying to develop new gases. Our latest gases are ammonia electrochemically and nitrogen dioxide. It's got an interface bus for expansion into new technologies. So when we came out with ozone, which was an electrochemical, we had a way to just use a lamp and generate that ozone gas with our existing product. So the end user didn't have to buy a new product. He could just add this ozone generating source. So they're interchangeable and expandable, and they're intelligent. So the modules that go into them, these generating sources, because they're not a date stamped source that has been already compressed into a cylinder and begins to react automatically, it greatly increases the ability to deliver these products on time. Almost anything you would order from us would ship. If you order it today, it ships by tomorrow. We have them in stock. We just final test them and ship them out when they get ordered. So it's just a very simple thing to have on the shelf at your facility and use, and also for distributors of our products. It's a great, easy thing to get. You call us, we ship them, usually 1 to 2 days. So as I mentioned, here is what one of our instruments looks like. This is a Jenny. The small cell is what a chlorine or a chlorine dioxide electrochemical cell looks like, and then on the left, that ozone module is what the ozone source looks like. So this one instrument, we show you the front and the back of it and the source. You can use that one instrument, calibrate chlorine, chlorine dioxide, and ozone if you have all three of those. So I'd like to thank everybody for attending. This is our talk about limited gases, ozone, chlorine, and chlorine dioxide. We have other ones, and I really appreciate your time today. Thanks.
Thank you, Kevin. So that's very interesting. there are a few questions which we'll take at the end of the session in about 10 minutes. I'd like to just show a few slides on Spantech and how we fit into the picture, which are now in front of you. So I'm Christian Rain. You can see my name there and email address for contact should anyone need to do that. I'd like to just spend 5 minutes on Spantech. At the moment, you can see that as well on the handout section that the ACD brochure that we created is now available for downloading directly from the web page at the same time. Spantech was formed in 1977. We deal solely with solutions for calibration gases. That covers a number of different products. The main ones I'll just run through quickly. We obviously provide calibration gas cylinders. Two basic product ranges there. There's the porta-gas cylinders that we sell. These are often called the green cylinders, as you can see from the picture, for good reasons. They're US made. They're the company that was set up many years ago by Kishore Parikh and was recently, well over 10 years ago, bought by Praxair. The products are made to very high standard. There are preparatory treatments of the cylinders and cylinder wall to ensure the highest quality product. Each cylinder has a unique serial number and certification of analysis with NIST traceability. We provide a wide range of ppm level gases. A number of certificates, they comply to the ISO 9001, but also ISO 17025, which is the lab qualification, 17035, which is the reference material standard, and also 7866, which is the cylinder standard. By doing this together with the unique treatment of the cylinders, they can provide very high quality, very stable, long life ppm level gases. The other range of cylinders we do is the Spancan cylinders. This has been providing value in cylinders over 25 years ago. These conform to the older ISO 6142 standards, which is the gas mixing standard. It's got many parts. Part 1, I think, is gravimetric, and in fact, part 11 is electrochemical, with reference to the ACD generators. We fill them in the UK, India, US with our trusted partners. They are disposable cylinders up to 110 litres. There is batch certification provided, and we do own labels for a number of companies around the world. So it may not say Spancan on the cylinder, but it may be underneath. With regard to the gases we're talking about today, cylinder options, we don't really have any cylinder options in ozone and chlorine dioxide. We do, of course, in chlorine now, in the porta-gas or the Spancan, certainly 5 ppm upwards, but in some cases 2 ppm upwards. And you can see we do up to 110 litres, porta-gas 116 for Spancan in the aluminium disposable cylinders. Well, Kurt's already talked about these. So there's another part of our range. We will market the generators worldwide for ACD, I would emphasize again the low operating costs, the ease of transport, which is fantastic because I can just carry it onto a plane whenever I want to go somewhere. Put it in the hold because it's got liquid in it, but there's no gas, so It's safe. The airlines consider it safe to carry in the hold. Very useful. I just thought I would talk about the options again with regard to chlorine, ozone, and chlorine dioxide. To summarise what Kurt presented, there's a wide range of options from ACD for chlorine. There's very low cost bump testers, which can be converted into very low cost generators. These are handheld, in fact pocket sized options, but they are fixed in their ppm output. They're not variable, so you will have to order the ppm that's of interest to you. In many ways, like a cylinder, it will give you one output. Otherwise, we do have more complex generators, as Kirk described, which for chlorine will give you variable ppm and will give you variable flow rate options from parts per billion, 50 parts per billion, up to 50 ppm. The internal pump will generate up to 1 litre per minute, but you can add an external pump and you can generate 5 litres per minute, and it will still hold its calibration and give you the ppm output that you desire. There's less options for ozone, but basically we can generate ozone up to 1.4 ppm. That we do have options for fixed ppm or variable ppm output. And chlorine dioxide we can generate up to 5 ppm. Again, working on a 1 litre per minute on an internal pump. So those are sort of ranges that we're talking about with these generators. And you can see, compared to the cylinder options that I presented, that's a wide range of options, a wide range of things you can do, which just you can't do with the cylinders that we sell. So as an example of the handheld generators, we tend to call them the mini bump because they're used for bump testing. But as I said, you can change the cell and you can get a continuous output from them. To give you an idea of the size, basically that mini bump unit will fit into the top pocket of my shirt. So it's very small. It will only do of the gases we're talking about today. It will only do chlorine though. It will additionally do some of the other gases like hydrogen sulfide, hydrogen cyanide, and hydrogen, but it's not an ozone or chlorine dioxide generator or bump tester. As well as that, we also Spantech sell replacement gas sensors. We're best known for selling the city sensors, but actually we do provide from a wide range of different manufacturers, providing the best solution for your problem on your budget. This is what we do. We've been doing this now for 25 years, since the first electrochemical cells were developed, and something we do for many international companies, and we do try and offer sensors at the best price we can, and but also trying to offer to smaller customers who will need smaller quantities. Occasionally we have offers on particular sensors that we're trying to promote. In this case, it's the 70. This month is the 70XV from cities that we're promoting this month. And if you're a sensor to use, it's a good time now to come to us and order your supplies. Do keep in contact with us if you can. If you're interested in these type of technical seminars, the easiest way to find out news about the forthcoming seminars, there are none in August because it's typically people are away on holiday, but we will start again in September, and in September we plan to have a seminar on cylinder technology and cylinders for ppm calibration gases, and that will be announced in coming weeks. Otherwise, our webpage, spantech.co.uk, is a good source of information, and you of course, email info@spantech is a good way of making sure that your email gets picked up and dealt with promptly. With that, that's my run through of Spantech. I hope that made sense. I would like to invite Kurt back to the stage, and we'll start to look at the questions that were generated during the talk. Kurt, if you're back there.
Yeah, I'm back.
Yay! Okay, I'm just going back up, scrolling up to the chat, and we'll try and take them in the order. In fact, as Sam has beaten me to it and put them on the screen, which makes my life even easier, and I do like an easy life. So the first question is from Milan. I'm going to, just my memory says from Serbia, but I'm not 100% sure, so I apologize if I'm wrong. Is the ozone sensor sensitive to wind or pressure higher than atmospheric by 50 to 100 millibars? If that is the case, if it is sensitive, does it have false alarms in that situation? So I think this may be a question more about the sensor than about your.
Yeah, I was going to say, is that
so possibly not your area of expertise. Probably the area of expertise of people on this call who might have an answer and be able to type an answer into the chat box themselves, because I'm not 100% sure of the answer myself. Maybe on that one we'll wait for other people to answer.
I can tell you, Chris, that my experience with the ozone sensors are when we have high ozone days here in the desert, and you alarm at such low levels, typically with ozone sensors, that a lot of times you'll get a false alarm. It's not really a false alarm; it's an alarm because there is a half a ppm in the air in the room. So it does happen in certain environmental conditions where you get an alarm. I'm not sure. You guys will have to get back to him on that atmosphere.
Yeah, we'll sort out an answer from Spantech on.
Environmental conditions can cause ozone sensors to go into alarm, for sure.
Okay, well, Milan, we'll come back to you on that. We'll get other people to answer that for you. Because interesting. Okay, so next question. How often do these gas generators need recalibrating? This is a good question.
And I don't think I touched on it in my talk. The instruments are calibrated to NIST standards, and those expire annually. So the instruments and the sources last for 1 year. Excuse me, of their NIST standards. Their NIST certificates last for a year, so they can come back into us then and be recertified if they're not consumed by that time. So the instruments come in annually to be certified. Usually the sources themselves, they're the consumable product, but they, again, if you haven't used them up in here and you want to just get them recertified, you can do that. So the answer is 1 year.
But they don't stop working after 1 year. I mean, it's not.
No.
It's just,
all that happens is the certificates have expired. The instrument and the source are still working.
The next traceability expires, basically.
Yes, just the way NIST works.
So we are now doing recalibrations for the units in the UK. Just to probably add that with Richard. So for the standard recalibrations, it's there's no longer a need to send things out of Europe to the US. We have typically that does reduce the turnaround time on the calibrations by as much as 2/3. And I think we've been doing some of the cells as well now. So we're starting to improve and increase the local serviceability in Europe, which has always does reduce the downtime, as I say, by up to 2/3.
Absolutely.
Okay, the next one I think is for the ozone generator. Can I have one fixed flow with fixed ozone ppm generating and variable flow with variable ppm outputs? What are the limits in the case with the Genie? Which I which I believe are factory set at the time of order placement.
That's right.
Yep.
So the ozone generator is a little different than the other generators in that we send a fixed amount of energy to the lamp all the time. And the way we vary the output, the standard unit goes, you can select between 0.2 and 1 part per million. And what we basically do is just increase the flow rate to give you less ozone. So if you set the ppm level to 0.2, the flow rate is 1 liter per minute. If you set the concentration level you want to 1 ppm, the flow is 0.2. So if you have a sensor that needs a fixed output or a fixed flow, you can also order it that way for the same cost. The ranges are at 0.5 parts per liters per minute of flow. You can get from 0.2 up to 1.6 parts per million fixed. And then at 1 liter per minute, that range goes up to only 0.8. So that's your range. You can order, say, a lot of people order half a ppm, 1 liter per minute is a common. So if you just specify that when you order them from Spantech, they'll fix it that way. It's the same cost, and that's how you can get your fixed flow or output. The standard unit is variable output, 0.2 to 1 ppm.
Okay. A question in Spanish from Jose, which is related to the disposal of expired cylinders. So yeah, he's asking if he can remove the valve completely and dispose of them completely empty and dispose of them in the way of aluminium or metal. I think that's quite a complex answer because of safety concerns. So again, Jose, will send an answer to you directly on that from the people from Spantech here, who understand the safety implications of messing about with the valves on empty cylinders. I could put it that way. So yes, we'll answer that, but we'll answer that in. We need just take a little bit of time to answer that, so we give you safe and reliable advice. Okay. In addition, with the ozone generator, there is a UV lamp. What is the life of the UV lamp, and what is the maintenance do you require on the UV lamp? And do you need to recertify annually and replace the UV lamp annually?
So we're typically, what happens is when you run that generator, the ozone source is timing down from 100 hours of use. So after 100 hours, it continues to go, but it'll say send it in for calibration. We're getting at least 500 hours. If you've used one of these generators, that is a lot of calibration gas. So not very many people are going through them. So no, typically they come in for calibration every year. There's no maintenance for you to do on the unit other than to send it in for calibration, and every 100 hours it'll tell you it needs to be calibrated.
Okay. Good. So I think the last question we have is regards to chlorine dioxide generators. In the chlorine dioxide generators, the electrolyte needs to be changed every 2 months. Can you please tell us why? So the observation is the chlorine generator, the electrolyte can last for years. How does ACD manage the problem to ensure that the generator will last for at least its 12 months, 1 year NIST certification?
So the chlorine dioxide is a really tricky chemistry, and the only way we managed to be able to generate that gas, by the way, we're the only people that manufacture a chlorine dioxide generator for anything. So this is the unit to calibrate chlorine dioxide sensors. The only way we managed to do that was to make, when you buy a chlorine dioxide generating source, the source comes full of electrolyte, and it comes with 5 replacement electrolyte packs that we suggest you you replace every 2 months. So the reason that is the electrolyte itself is light sensitive, so it degrades over time. It lasts longer than 2 months, but again, to be overly cautious, it's built into the price of the generating source. It doesn't cost you any extra, and you have that. Now, if you calibrate every quarter, then you just change your electrolyte every quarter. It's, you know, people who use them on and off, we suggest every 2 months, and that's how we ensure that they stay within specification. If they're changed every 2 months, we're sure, and we've done all the testing for all these years to make sure they're going to stay within specification, and IST-wise, for your 1 year certification.
Very good. Yeah, it's a very simple process to refill the electrolyte. I remember with a very simple pipette. Sort of thing that most labs will have. Very good. And as you say, it doesn't affect the calibration. Just doing the refilling. That's correct. Not a factor on it. Very good, Kurt. Thank you for that. That's questions. I've been through all the questions that were given, and we're almost up with our time as well. So, may I say thank you for everyone for attending. There is a link at the moment on the bottom left page to our LinkedIn page. I'd recommend to go there. If you follow us, you will always be sent news of upcoming technical seminars around calibrating instruments or servicing instruments in the field for ppm gases, and please do follow that. Aside from that, thank you to Kurt, thank you for Sam for organising this, and thank you to everyone for attending. I hope it was a useful and interesting seminar for you.
Thanks everybody.